So now we will be seeing the experiment number 10, which is the Discus algorithm. So what is Discus algorithm doing here is, it is finding the single source shortest path. So one source will be given, from that source to all other different vertices, what is the shortest path available. That is what we are going to find here. So let us see how we are going to do it. So in the first line of the program here, we are importing the scanner class for reading the data. So next I am creating a class called as Discus class. In that, see, for Discus we are having the distance row and a path row. So that is nothing but a single dimensional array. So we are creating D and P, two arrays dynamically in the Java programming language here. Next, visited, one array is created to know whether the particular vertex is visited or not visited. If it is visited, then visited of I will be 1. If it is not visited, then visited of I will be 0. This is how we are going to check whether a vertex is visited or not. So next we are having here, we have created a function called as Discus here. So what we are going to do here, let us see. So here U is the considered as a temporary source vertex U. So it is initialized to -1. V is the next adjacent vertex. I, J are the loop control variables which we are using, and min is nothing but the distance between the two vertices U and V. So for starting from V is equal to 0, V is less than N. What is N here? N is total number of vertices. Then V plus plus, what we are doing here, initializing the distance array and the path array. Distance array is initialized to 99. It means we don't know the distance from the source vertex to all other vertex. So initially it is given the value of 99. Then path also we don't know, from source vertex 0 to next which vertex we are moving. Then from that we are going to which vertex we don't know. So initially we are giving the value for all the values of this path as -1. Then what we are going to do here, D of S is equal to 0. Since 0 is the source vertex which we are using here, so it is always initialized to 0 first. So it is always initialized to the source vertex, that is 0. Then what we are doing in the next one, let us see. For I is equal to 0, I is less than N, I plus plus, minimum is equal to 99. Means the value of minimum is initialized to 99. Why we are using this here is to check whether there is a edge between two vertices. So if there is a edge between two vertices, obviously the edge will be containing its particular weight. If there is no edge, it will be containing 99, because initially we have initialized the distance vertex to 99. So if there is no edge, then 99 will be present, otherwise its particular weight will be present. So that is what we are checking in this line here, whether D of J is less than minimum and visited of I is 0. Means whether there is an edge between the vertex and it is not visited. If it is not visited, then we are going to visit and store its adjacency matrix and store its weight of that particular edge. So min is equal to D of J. Means if there is an edge, then the edge value weight will be taken as D of J, and U is equal to J. Means the next temporary vertex we are going to take the adjacent vertex here. And since we have visited that adjacent vertex, visited of U will be taken as 1. So this is continuously done. Next what we are going to do is, we are going to find the minimum cost here between those two vertices I and J, that is U and V. So this formula we are using here, we have seen this formula in the theory also. So the formula is containing the temporary vertex U and its temporary source vertex U and its adjacent plus the adjacency matrix value, that we are doing and calculating the value of the cost here. So after calculating the value of the minimum path, one by one for all the from source to all other vertices, the cost is calculated. Then this will end the how to find the cost and whether there is an edge between two vertices to check that, we have done with the code. Next is now we are going to find the path here. So from source vertex to next adjacent vertex, next adjacent vertex to its adjacent vertex, like this we have to find the path here. So to find the path we are going to use this part of code here. So then what we are doing, we are printing this with the help of this small arrow. So from source vertex, this arrow to the adjacent vertex V, like this we are printing. This is to find the path and update the P array, and update the P array. P array is what? It is the path, so we are updating the P array. After updating, P array will be containing the path from the source vertex to the different adjacent vertices. Next, what we are going to display the whatever path we have got. So to whatever path we have got, that will be displayed as from the source node to its adjacent nodes, and it is calling the function path here. From the source node to the path, what this path will do is, it is finding the adjacent vertices of that source node, which we have seen in the previous code. So this will complete the printing here, and after printing, what we are doing, we are printing its particular distance. So what is the distance from the source node to its adjacent, to its next adjacent? So that is present in the distance d of I, that will be printed here. So now in the main function, let us see what we are doing. The main function, we are creating an array A. This is for the adjacency matrix. We have to create I, J, N, S. These are the variables which we are using here. Initially we are printing a message for the user saying enter the number of vertices. So it is asking me to enter the number of vertices. So I have to read the data. To read the data, we want the object of the scanner class. So SC we are taking here to create the object of the scanner class. Then N is equal to next end. Whatever the number of vertices is entered, that is stored in this N variable using this next int function from the scanner class. Next we are taking the enter the weighted matrix, means cost adjacency matrix we have to enter. To enter this cost adjacency matrix, first we have to draw the graph, then its corresponding adjacency matrix will be entered, and that will be stored in the array A of Ij. So then we have to enter the source matrix. So what is the source vertex we want, from which source, that we have to enter here, from 0, either from 1, from 2, from where we want to enter the source vertex, that we have to enter here. Next we have all the input data. Next, what is the line? In this next line I am creating the object of the Discus class. Why? Because Discus class itself is having the logic for finding the distance and path from the source vertex. So tr is the object created of the Discus class. So tr dot Discus A, S and N. A is the adjacency matrix, S is the source, and N is the total number of vertices. So once this Discus function is executed, then what will be having? We will be having the shortest path here. So means it will calculate the shortest path, and we are going to print using the display function, which we have seen before in this program. So this is how the Discus algorithm is been executed. Lastly, we are closing the object of the scanner class, that is sc.close. So this is how we are seeing. I will show you the output with the help of a graph itself here. So this is a graph, it is having 4 vertices from 0 to 4. So that is 4 vertices. For this particular graph here, I have written the adjacency matrix and enter the source vertex as 0. So now let us see here, we will execute the program, but I will explain the output here itself, because graph is here. So I will explain the output here itself. See now, enter the source vertex 0. So 0 is my source vertex here. So from 0 to 1, what is my shortest path? 3 is the shortest path, that is given here. Then from reaching 1, next I want to reach 2. For reaching 2, I have to move from 0 to 1, 1 to 2. This is the path which will be stored. And what is the distance? 7. 4 plus 3 is 7. So now I have reached from 0 to 1, 1 to 2. Then I have to reach 3 here. So I can reach 3 with the shortest distance where? See, I can reach from 0 to 1, and from 1 to 3 I can reach. See here, 3 plus 2, 5. So 5 is the shortest distance. Next is 4. So how can I reach 4? 0 to 1, with the 3, 1 to 3, that is 2, 3 plus 2, 5. Then from 3 to 4, that is 5 plus 4, 9. So 9 is the shortest path from 0 to 1, 0 to 2, 0 to 3 and 0 to 4. This is how we are going to do. Now let us execute this one. So now I have created a Discus program here, program number 10. Let me save this once. So after saving, we will run this program. So now it is asking me what is the number of vertices. We have taken 5 there. Yes, 5 we have taken. Enter the cost adjacency matrix. It is asking me. So I will enter this same cost adjacency matrix. So after entering, it is asking me the source vertex. Source vertex I am taking as 0. Then see here, 0 to 1 is 3, from 1 to 2 is 7. Same output we have got here. So this is how we are finding the single source shortest path using the Discus algorithm.